All right, you ready? So you can see the board, right? It's more about the board.
Yeah.
If you need to scoot back, just have her move. All right, 3. You guys need to be quiet while I do this. So if you can't be quiet, put your head down and go to sleep or something. I'm just kidding. Don't do that. I'm just joking. Don't really do that. All right, 3, 2, 1. All right. So we've already talked about ionic bonding, and that involved a metal and a non-metal, involved the transfer of electrons, and most of those are solids. All ionic compounds are nicknamed salts, okay, and it's between cations and anions. The cations are the metals, which are positive ions, and the anions were negative ions, called anions, which are the non-metals. Right? Now, we had the law of definite proportion, so that's why we had to do the crisscross method and cancel out the charges. So if I had the metal as a +2 and this non-metal as a -3, we would crisscross and reduce to find the lowest common denominator, and that way we would get our formula units, which are the subscripts, and there's only one way to write those, okay? And because the total charge had to be 0. Now, today we're moving to covalent bonding. Covalent bonding does not include charges or none of that stuff matters. It's involving 2 or more non-metals, so everything to the right of that staircase on our periodic table, and it involves sharing electrons. And the way I remember that is ionic is like I'm selfish, I'm taking electrons. Covalent is like the covenant of marriage, and you are sharing. Okay, when you get married, you need to share. Okay, if you don't, you're not going to be married long. Okay, so the covenant, the covalent is like a covenant where you're sharing electrons. All right. Now, because of that, we use the law of multiple ratios, and because there's multiple ratios, there's a lot of different ways it can exist. So you could have something like, CF3, you could have C2F8, you could have C3F6. There's multiple ways to write these nonmetals together. And because of that, we're not canceling out charges, all right? You just have to write what's there, all right? And so when you name these, you're going to use what we call prefixes, all right? And the prefix tells you the number of atoms and then the name, and then you're going to have a prefix and say the number or the name plus IDE, just like we did with the nonmetals before. So those prefixes are the following. Mono is 1, like mono is 1 on 1. Di is 2, okay? Tri is 3, like a tricycle. Tetra, like the game Tetris. You get, the long stick clears 4 rows. That's Tetris, because you clear 4 rows. That's tetra means 4. Penta is 5, like a pentagon. A hexagon has 6 sides, right? The hardest one's probably hepta, because we just don't use 7 that often. So a hepta is 7. Octa is 8. That's easy. An octopus has 8 arms. Nona is 9. 9 sounds like nona, so it should be similar. And then decade, like a deca, is in decade, like 10. All right? So it's mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Those are our 10 prefixes that we're going to use in our nomenclature. So when we do these, you're going to have a prefix and a name and a prefix and a name. So you're going to look at it. If I have like, N2Cl5, then it's prefix name. So it's dinitrogen, keeps the whole name of the nonmetal, and then pentachloride. So that's how I would name that. Dinitrogen pentachloride. So it's prefix name, change to IDE. So it's actually very simple compared to the ionics. All right. Now there are a couple of different rules, like the following. You do not need mono on the first element. So if it's just 1 for the first element, you just say the element's name. So this would be carbon, but you have to have mono on the second. So if it's just C and F, it's carbon monofluoride. All right? So carbon monofluoride. So you have to have mono on the second element, but you don't use it on the first. So if I have this would be sulfur monobromide. I think I spelled sulfur. There we go. Sulfur monobromide. So like I said, no mono on the first element, but you have to have it on the second. All right? Now, the other rule that you have to look out for is dropping the A and the O on the prefix. So like how it's the A's and the O's, like tetra, penta, hexa, you drop that A on the end. You would drop O from mono if you're using oxides or iodides. All right, so if I have something like this, if I have, P2O4, that's going to be diphosphorus. And then instead of tetraoxide, it's tetroxide. So I drop that A. All right? And if it was P2, we'll say O6, then instead of being diphosphorus, and then this is hex oxide, I drop the A from that. All right? So everybody see that? You drop the A on the prefix when using oxides. Iodides, you do the same thing. So if I have, Si5, that's going to be sulfur pent iodide. So I drop that A on penta. All right? And so you only drop them for oxides and iodides. Now, the I's you would keep. So if I have like an I2, like if it's like Si2, that'd be sulfur and it's diiodide. So you would have two I's in a row. All right? So the I's you keep, but you drop the A's and the O's. All right, then the third one is if H is the first element, then it's an acid. So if you have like HCl or HBr or H2S, all right? And we have a special name for those acids that we're going to get to when we get to acid nomenclature, all right? The only exception would be H2O, and that's water, all right? And if you put dihydrogen monoxide, I'm okay with that. NH3 is ammonia. That's another special name one. So if you see the word ammonia, that equals NH3. But if you put nitrogen trihydride, I'm okay with that. And then another one would be CH4 is methane. All right? And that's another special one. So ammonia, water, and methane. Okay, if you put carbon tetrahydride, I'm okay with that too. But if you write methane, that's what it is. All right, so we will get to acids when we get to the acid unit, so I won't give you those on quizzes or tests. But just remember, if the first one's an H, then it's going to be an acid. All right, so that does it for writing and naming compounds. So we're going to practice two and see how we do here. So if I am given a name, dicarbon hexafluoride. All right, how do I write the formula for that? Well, I always underline the prefixes because that tells me, okay, this is my element, that's how many I have. Carbon, it's dicarbon, so carbon I have 2, and then fluorine, and I have 6. So it's C2F6. You see how easy that is?
So easy.
All right, I'm glad you're loving it. All right. Now, the last example. Let's go. What if you have like, Se5 I9. All right. So this one, 2 elements that we don't usually use that much. So it would be pentaselenium. Nona, except you drop the A, right? So it's non-iodide. So non-iodide. Pentaselenium non-iodide. All right? You got it.